In this video, we will learn about the two main layers of our atmosphere. The troposphere, full of weather and bad ozone, and above that the stratosphere, where good ozone protects us against dangerous ultraviolet light. Our atmosphere is made up of gases, mostly nitrogen and oxygen. They are held to the Earth by gravity, a sort of ocean of air. Because air is compressible, it gets less and less dense as you get further from the Earth. Let's consider the first 50 kilometers where 99% of the atmosphere is found. Visible sunlight passes through the atmosphere and warms the ground, heating up the air at ground level. As the colder air above sinks, it pushes up the warmed air, which is less dense due to expansion. This movement, known as convection current, gives us our weather systems. The atmosphere gets colder and colder till you reach about 10 kilometers, the tropopause, where the temperature is coldest. Below this is the troposphere, containing 80% of our air, and all the weather. Above the tropopause we have the stratosphere. This is a layer of thin air which is hot on top because it's heated from above by ultraviolet radiation absorbed by the good ozone and cold underneath, making it dynamically stable. Contrast this with the turbulent troposphere. If you have ever flown in a jet aeroplane, you may have had a bumpy ride after takeoff through the turbulent troposphere, but once you're above the clouds, above the weather, your journey is smooth. Propeller planes cannot fly this high because the air is too thin for the propeller to grip the air. So where does this good stratospheric ozone come from? Pause the video and think of the formula of ozone. Well, ozone is an allotrope of oxygen. Its molecules are made of 3 oxygen atoms bonded weakly together. It is an unstable gas which slowly decomposes back to molecular oxygen. The ozone in the stratosphere is continually being made and broken by the ultraviolet light in the ozone-oxygen cycle. To start with, UV gets absorbed in the stratosphere by molecular oxygen, which splits into 2 fast-moving atoms. These fast-moving oxygen atoms collide with air molecules around them, nitrogen and oxygen. This slows the free oxygen atoms down, enabling them to bond weakly with the molecular oxygen to form ozone. If they're moving too fast, they simply bounce off. The energy they shared with the molecules in the air heats up the upper atmosphere. The oxygen atom has now joined with an oxygen molecule to form ozone. Ozone is very effective at absorbing ultraviolet light, which causes the ozone to split back into an oxygen atom and an oxygen molecule again, keeping the upper atmosphere warm. Ozone reforms as before once the oxygen atom is moving slowly again. The ozone is spread out through the stratosphere, shown here in black. Why do you think there is so little ozone high up and low down? Remember, we need ultraviolet radiation and oxygen to make ozone. Pause and think. Well, here there is too little oxygen, and here, near the tropopause, the point of lowest temperature where the troposphere and the stratosphere join, there is no ultraviolet light available. It has all been absorbed by the ozone further out. So this is the ozone layer. If the ozone were squashed together like a solid, it would only be the thickness of a sheet of cardboard, but it is actually a gas spread out over 20 or 30 kilometers. Before our atmosphere was filled with oxygen, the UV reached the Earth's surface and prevented life from emerging onto the land. Ozone is also present in the troposphere, formed mainly by the action of sunlight on pollution from motor vehicles. Here it helps to form photochemical smog and is a pollutant. Learn about the famous hole in the ozone layer and why it has got thinner. We will also look at the action the world has taken to restore it back to health. To find out how stratospheric ozone is made and how it stops harmful UV from reaching the ground, view part A of this video. In the 1980s, scientists found something alarming happening over Antarctica during October when the sunlight returns to the South Pole after winter. The ozone had almost disappeared over large areas, causing the famous hole. An aircraft which analyzed the composition of the air flew due south 15 kilometers above the Earth, in the stratosphere where the ozone is most concentrated. They found that the ozone there suddenly became replaced by chlorine oxide. This led to the realization that the chemicals called CFCs, chlorofluorocarbons, were to blame. These are inert, stable molecules and were once the wonder chemical used as the fluid in fridges and air conditioners, to expand polystyrene, and in aerosol cans to propel hairspray and paint and so on. They were completely harmless to animals. So what went wrong? Well, CFCs are so inert that they do not get washed out in the rain or broken down in the troposphere, so they diffuse up into the stratosphere. Use your knowledge about how ozone is formed to think about what might happen to CFCs in the stratosphere. Pause and think. Here they are bombarded with ultraviolet light, which breaks chlorine atoms off the molecule. These then bond with the free oxygen atoms, preventing them from reforming ozone in the ozone-oxygen cycle we saw in the first part of this video. When the chlorine oxide meets yet another oxygen atom, molecular oxygen reforms, leaving the chlorine atom to continue to remove more atomic oxygen. These chlorine atoms are eventually removed from the stratosphere naturally, but not before they have captured thousands of ozone-forming oxygen atoms. Thus the ozone-oxygen cycle was being destroyed, and the ozone layer was thinning all over the world. Thus, in 1987, the Montreal Protocol was signed by all nations of the world, banning the production and eventually the use of CFCs. They have been replaced by HFCs, hydrofluorocarbons, a similar molecule which contains hydrogen in place of chlorine, making them a little more reactive and so able to be broken up in the troposphere before they reach the ozone layer. Because the chlorine is slowly and naturally removed from the stratosphere by complex photochemical reactions, and because the ozone layer is naturally reforming all the time by the action of UV on oxygen, we expect the ozone to return to its original level in 50 or 100 years' time. The hole in the ozone layer allows harmful UV radiation to reach ground level, which can cause skin cancer. However, a common misconception is that it lets heat in and causes global warming, and this is not true. Ozone is also generated in the troposphere by a complex series of photochemical reactions on the products from vehicle exhausts. Here, in the troposphere, ozone acts as a greenhouse gas and helps in the formation of photochemical smogs that pollute certain cities worldwide from time to time, for example, Los Angeles in the USA and Beijing in China.